Go. Hello, welcome everyone. This is our 7th webinar in the Responsible Hillside Living series. I'm Robert Thompson, Faculty Workshop. And today we're talking to Aaron Rampersad. Aaron is a geotechnical engineer working at Beston Consulting. He has a passion for rocks. He has close to 10 years experience and has worked on various projects all over the Caribbean, civil or structural. And he's here today to educate us a little bit about what geotechnical engineers do. Aaron, welcome. And thank you for being
here. Thank you.
So, first thing, what does a geotechnical engineer do?
Well, that's a very good question, because it's a common misconception what we exactly we do. So perhaps it's good to start a little background in terms of soil mechanics or geotechnical engineering. Is a very young field. It was really only formalized in the 1940s by a guy called Karl Terzaghi, right? Geotechnical engineering is technically just another arm of civil engineering. So you'd find that most geotechnical engineers are also civil engineers. I'm not saying that's not the only route, right? Because during my master's, there were people who are geologists who were doing geotechnical engineering, but most geotechnical engineers are civil engineers. And we will see later why later on. But basically, what we do is study subsurface conditions, try to identify any associated risks with those subsurface conditions. So therefore, we have, I guess I would say, a wide area of application. For instance, it could be general construction, so for foundations, for retaining walls, stuff like that, or we could go into oil and gas industry. Geotechnical engineers also working at even marine as well, and even just a point about how young it is that now tailings dams and dam construction that also now falls under geotechnical engineering. So basically, in summary, we deal with everything that is subsurface and try to derive engineering properties and any associated risks of constructing in those subsurface, both short term and long term.
Right. And how do you do that?
This can be done in several ways. I mean, the most common way, obviously, is to go on site, inspect visually, in cases where you are like Trinidad, where you have outcrops on the north coast, you'll be able to classify those rocks via field testing, acquire properties like UCS strengths. Another common way is borehole investigations, whether it be so borehole investigations, for those who don't know, it's you probe into the ground. It's called, you have SPT testing, which stands for standard penetration testing, where it's the amount of blows taken to drive a certain depth. And that gives you the consistency of the soil. Right. There's also CPTs, which is continually pushing a cone into the ground. So it's like, if you keep pushing the ground, and the softer it is, the less resistance, the harder it is, the more resistance. So you'll get a different reading. Right. That's the second most common way. And then you also have test pit investigations, which are also pretty common and fairly cheap. It's actually a lot more common for residential because sometimes people can't afford to do full geotechnical investigations. So they just do test pits and may call an engineer to witness these test pits and give some idea of the bearing capacities and possible long-term settlements.
Right. All right. And that leads us into the next question for, like, who does a geotechnical engineer serve?
But first and foremost, ourselves. Well, I mean, that's why I started off saying that geotechnical engineers are civil engineers. So on large scale projects, we generally serve the structural engineers. generally, more often times than not. On smaller scale projects, like if we are doing landslip rehabilitation or new wall constructions, that will basically be saving ourselves because geotechnical engineers do also indulge. Well, once you are a civil engineer, you can also carry out to some degree structural designs, right? Obviously not large scale structural, right? But primarily for large scale projects, we save the structural engineer.
Okay. So
But we also, I mean, again, it goes back to the nature of the project. For instance, in landslips, for instance, the Ministry of Works, they would call a geotechnical engineer to deal with that. So in that case, we serve the client directly.
And what information do you give to a structure? So for small residents, what information would you produce for a structural engineer to use?
Generally, at the bare minimum, we will, well, we a seismic region. So we will give the site classification, whether or not you have risks of liquefaction, ground amplification. I mean, we were all terrified of that. I think it was 2018 earthquake, that shook.
Yes.
Right? And generally provide bearing capacity as well. That is basically the safe working load or the weight you can apply to the soil before it yields and you begin to get excessive movements, like seen in this very graphic picture. We also give settlements, like settlements associated with those load, because another misconception is that a lot of people ask geotechnical engineers, "Oh, I just want the bearing capacity." But bearing capacities are associated with a settlement. It's like load and deformation. If I apply a load, it's going to give me associated settlement. So it's like a twice-fold scenario. We also provide, but this goes more into civil engineering. We also provide, for instance, if someone is building in maybe close to a ravine or a river, which is common in sloped areas, you want to know embankments. If you want to construct an embankment or road for access, you need to know what sort of slopes are stable, you know. And even for the structural engineers, sometimes they may not want to have a wall all around the house and property or the building. They may want to slope it. So our job is now to say, to tell them what is your safe working slope for long-term performance in terms of without any excessive slips and so on.
Right. So
and we also provide, like, sometimes, again, if we don't do the designs, as in the retaining wall designs, we also provide them with the angle of friction, the cohesion, the unit weights, bare minimum engineering properties, basically.
So if a layman called you and there's no professional involved, what could you provide them? Apart from advice to go apart from speak to another engineer as well. But then you could also do all the work for them, I suppose.
Of course, of course. Well, again, it depends on what the layman is looking for. I mean, well, for the past couple of months, given our heavy rainfalls, I've been getting numerous calls about landslips. So, I mean, a lot of common people call me and ask, I have a landslip, come see it.
Right.
At that immediate visit, so the first step is a visit. After I make the visit, I can start guiding them and giving them ideas of what to do. Right? So I can tell them, look, right now, based on my experience and expertise, I can tell you, if you cover the slope and protect it or pin it, you should be fine until we can come up with a more robust solution to this. So we can provide the layman with guidance at an immediate call without any sort of investigation. We can also advise. Sorry.
What do you mean by pinning the slope?
So pinning the slope has to do with you can use steel rods just to pin the slope. So basically, the pin, like if you what you have on this image right here, which is polythene sheets. So you basically pin that to the slope. What that does, it basically continues to protect the slope from any excessive erosion and washouts and so on and so forth. Because we're in a tropical region, right? I mean, rain can happen at any time, right? And if you have a field surface, the last thing you want to do is for water to continue to saturate that field surface. Then it's going to keep breaking away and breaking away and breaking away.
Right. Now, you mentioned liquefaction earlier when you initially started talking about this question.
Right.
What are the risks here in Trinidad that what are the risks of that happening in
The
areas here?
risks based on I mean, this is just based on, according to our maps, based on the maps themselves, there is a moderate to high potential, right? Given that we do get an actual event to that magnitude, right? But based on our historical data, the magnitudes, even though they may have been appear to be 6.8, 7.2, what we have seen from processing the time histories is that, and the time history is the thing that, for those who know, is just the thing that gives that, right? So when you analyze that and actually analyze that deformation over time, you find that the actual ground motion, which is the amount of shaking experienced, is not that high, right? So I mean, the point stands that we can't have liquefaction potential. In fact, I think it's the Grand Bazaar interchange. The embankments there were designed for liquefaction. They have some piles in the ground by the embankment so that in the event of an earthquake, a very severe earthquake, it will be safe working conditions at least.
Okay, that's good to know. My next question is, I mean, when to call a geotechnical engineer?
Preferably before things go wrong.
All right.
It really depends. If you are looking to develop a site, particularly sites on sloping ground, I would suggest before you even touched or excavate the ground, or even during the process where you contact your architectural person, you have that discussion with the geotechnical engineer. Whether it be you just inviting over for a visit, an assessment, you should always start there at greenfield conditions. It's very important to start that, particularly with sloping sites. There have been sites that have gone on where they literally got in local Trinidadian terms hit 6 for 9 because they bought a property on a hillside, right? I mean, I can't disclose the location, but they got a property on a hillside, and when you're building a hillside developments, because it's sloped, you cut, bench, dump material on one side. So some developments are on fill and some are on the rock, right? And that person happened to buy and develop an entire property on the fill side of that material. So I think as that fill, because it's northern range philitic fill, it does not fail immediately because it has some potential, right? What happens over time with rain and uncontrolled water running off on it, it eventually saturates and slips, right? So again, if that person had called a geotechnical engineer at the beginning, it may have only required minor adjustments to his or her designs. Minor. And may have gone a bit deeper with the foundations, may have do some restraint or underpinning at the bottom, short piles. There are several things that could have been done to prevent that. In terms of you already built, I guess the first telltale signs is cracking. I mean, let me see if I can show you some pictures.
Okay, I'll stop sharing so you could show us something.
Right. Well, this was a picture I had just showing all the different arms of geotechnical engineering. So it's very, very broad. We touch base on all fields. Right. I mean, this is a bit extravagant, right? But I mean, this is one of the times you think you would call. You should call. You see cracks coming down your wall. You see, there's also signs above, like your doorway. It's the common one as well. You know, so the thing is, I mean, it could be structural crack, it could be related to a poorly designed structure, right? Or it could be due to settlement, which is a geotechnical issue, right? So again, I mean, let's say you call a geotechnical engineer and he comes and says, okay, it does not appear as if this is a geotechnical problem. He can now refer you to a structural engineer to make that structural assessment. So even though you think that the first person is a structural engineer, because a geotechnical engineer is also a civil engineer, they can also provide you with some degree of guidance and information to move forward.
Great. Someone just asked a question. Would it be possible, or, should it be allowed that a geotechnical report should be included with sloping sites as a part of the deed?
That's a very, 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 very good question, because to my knowledge, and anyone could correct me if I'm wrong, there's the EMA stipulates that any sloping land above 15 degrees requires an EIA. That is my knowledge. And an EIA, common misconception, I think, people think are done by environmental scientists. It is not. The premise of an EIA is actually geotechnical all around. If you think about it, what is an EIA? An environmental impact assessment. And what are you concerned with? How your property will impact the environment, which has to do all with subsurface conditions, where you put in your soakaway, how you control the water, are you contaminating groundwater, and stuff like that. So
Yes.
the question is, yes, it should be, but is it?
No. That's
No.
all on the buyer.
Yeah.
Okay, so what kind of basic landslip pointers, or like, I wouldn't say prevention, but like kind of delay methods can people do if they figure out that their land's prone to some event happening? You can't prevent it, but you can delay it maybe.
Right. So basic landslip prevention or delay methods, basically. The first thing you should look at is one of our enemies is like kryptonite, Superman for geotechnical engineers. It's water, 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 water. Your first step is to look at controlling surface runoff and surface saturation, right? A lot of developments tend to put perfectly flat land with no grade, with no way for water to run off during periods of high rainfall, right? And in the tropics, particularly during our heavy rainy seasons, soil does not get time to drain. And if the soil is fully saturated and it can't take any more water, it has no choice but to wash out, which is one of our most common failures, washouts.
Yeah.
In fact, let me show you an example of a washout. So this is what we would call a washout.
Wow.
Yeah, really surface saturation, and it slips. I mean, there are some other mechanisms involved here, but primarily because it occurred after a period of heavy rainfall. So the trigger was the rainfall of uncontrolled watery top. You see nice flat plateau on top. So all that water just falling there, infiltrating. And this is common northern range pholitic material, very susceptible to slippage. Yeah, and it just washes out. So definitely the first thing would be proper surface and subsurface drainage. The second step would be to look at your water, sewer lines, and grey water lines. Now, in hillside developments or on sloping land, no one likes to see pipes above ground. No one, right? So everyone puts everything below ground. The problem with that is that the earth moves. You can't get away from the earth moving, and things leak. Things always leak, right? And unfortunately, when it's on the ground, you don't see it when it's leaking before it's too late. So that's another thing you can also begin checking and monitoring. right? Am I getting enough pressure in my line? Am I seeing a constant wet spot of grass in my house, outside of my lawn? Is there a place where I walk and my foot sinks? And these are telltale signs. And
Right.
sometimes I remember there was a site I went on, and I was walking across the property, and it was very undulating. And I was like, "Why is the property undulating?" He was like, "Oh, well, sometimes this spot here is soft, so it sink, and then that spot here is soft, and it sink." I'm like, if only you knew from before when this stuff was appearing to fall, you may have been able to prevent the ultimate from happening,
Yeah.
which was a slip at the property.
Right.
Something else to look at is trees, which is kind of one of the things counterintuitive, right? Trees, trees should help, but in some instances, I'm looking for a picture to show you. In some instances, due to root jacking. So root jacking is, I mean, we all play in the ground when we're kids, right? So when you take a stick and put it in the ground and you rock that stick, that hole opens up very, very wide. The same thing happens in soil, right? You
Right.
have these hills on slopes and it rocks with wind, weight. Sometimes the tree, the branch overgrows and it jackets. And that causes instability as well. See.
So basically trimming that tree could help.
Yes.
Because then it's not
At
as
least
stale.
yes. At least relieve some of the weight. So we see this tree goes nice and through the rock.
Right.
Oh, this tree is fine. This tree is fine here because it's at the bottom of a slope and it's not exposed to any wind and such. But if this tree was at the top of a hill or a ridge and it's experienced all those the northeast trade winds which we experience, it will pose a problem. Not in immediate. These things don't happen immediately, but
No.
in the long term.
Because basically just rocking something free.
Yes.
Like a lever.
Exactly.
Right.
The term is called root jacking. It's very common phenomenon.
So water, your trees, anything else?
I'm thinking. Well, we talked about main trees. I guess in areas where you notice excessive movements, I guess you can begin starting to protect it. Like if you see areas where you have a lot of tension cracks, I have so many pictures to show. To prevent water from getting into that. This is in salt, right? So bad material. But the point I'm making is that if you have land beginning to pull away and you have these cracks opening, the last thing you want to do is reinforce for water to get into those and further saturate the subsurface. Because now you have an open conduit for water to flow in there.
Right.
So that's another method you can employ there.
Right.
Something else I didn't show, which I probably should show, which you asked the previous question about signs to look for.
Yeah.
And I love this picture. These are basically, in a nutshell, some of the signs you should look for with movement. Yeah. So I remember once going to a site and someone asked, "But why is the tree curved?" And I immediately turned around. I was like, and that is one of those telltale signs, because trees grow towards the sunlight, right? So if your land is susceptible to movement, it moves, it grows up. It moves, it grows up.
Right.
So the tree trunk eventually becomes curved.
Curved.
Yeah. So that's one of the telltale signs. Very, very common in the northern range. Very, very common in the north. It's something I always look for in north. And even working up the islands, even in countries like Grenada, St. Lucia, all those volcanic islands where it's susceptible to shallow mass movements. Trees are always a telltale sign of what is happening because a lot of those areas and hillsides are undeveloped, right? I mean, that's why you want to go there, away from people. So as you start to develop, it gives you telltale signs without doing too much investigation that this land is prone to movement.
Okay, great. So, key question. What are the typical costs associated with engaging a geotechnical engineer?
Interestingly enough, before this presentation, I had to research that. Not research that, but I had to actually get the prices we actually charge. So site visits can be from 800 to 1500 in the PT. It depends on, but sometimes that's all you need, right? A site visit. Sometimes that's all you need. Someone tell you, hey, okay, look, come and look at this to me. Is it fine? What do I do? So that's roughly around that range. Your technical report, because that's what everyone wants, right? Your technical report. That can range from whether it be from residential small scale, from whether it be to 10,000, 30,000 upwards, right? And again, the lower bound obviously has to do with smaller scale projects, upper bound is larger scale projects. And in that report, you would get the things that we discussed before, things like bearing capacity, safe working loads, possible settlements, stuff like that. Now, the geotechnical report is obviously complemented with the investigations we spoke about earlier, right? In terms of borehole investigation and test pits. But before I get into that, is that sometimes you may only need a test pit. Right. So that's why it's always really good to have the site visit first and have a discussion with the geotechnical engineer, whether it be your architect, the client, you have a nice little three-way conversation and say, what is the intention? So you can actually guide them on the way forward on what to do. Do you need a report? Do you need an investigation? So movements can be made without spending unnecessary money. Right? Borehole investigations. So 2 boreholes, which is the minimum required. If we say you need a borehole or boreholes, you need a borehole. I mean, we won't lie for that. So 2 boreholes at about 10-meter depth is roughly and laboratory investigations, right? So you won't do boreholes and not test the soil. Yeah. So those testing involves telling you the friction angle, water content, plasticity. Those range between 18,000 to 34,000. Again, it depends on where. Is that right? The last thing we have is test pit investigation, which is the most common and is obviously the cheapest. So 3 test pits that are roughly 3 to 4-meter depth with field testing. We'll work with our hand tools to test the soil. Ranges from 8,000 to 12,000. Sometimes the client, like I've been on projects where the client calls and they have a backhoe on site and they just pay for my site visit because I don't need to procure. Yeah, I don't have to procure the equipment to bring it. So they just pay my site visit. I watch them dig the holes. I go into the holes, unfortunately, and test it to make sure test it with my tools to make sure it's fine. Give them site recommendations and they move forward.
Nice. Just a follow-up on that. The EIA. How much does an EIA cost if you have to do one of those? What makes up an EIA?
The EIA will be very close to geotechnical report price, but the upper bound. So you're looking at between the same 10 to 30,000 roughly. Now, again, it depends on if the geotechnical report requires that you do a borehole investigation so that we can analyze that data to include there, then obviously the price will go up. So it'll be that price plus the price of the borehole investigation or test pit investigation. Depends which one warrants it, right?
All right. And when do you need an EIA? Because with the EMA, if you go in for a CEC, once you don't get a CEC, then you have to do an EIA to get clearance. Yes.
Basically, yeah. But again, I'm not sure how stringent it is right now. I mean, to my knowledge, if I'm being honest, I don't know how stringent it is. I mean, I know I've seen only a couple in Wells Springs, Port of Spain, but
we had to do one.
Yeah. Oh, I had to do one.
Yeah. Well, we always have to do on hillside. So once you're above 1 in 4.
If I know it's like 10 to 15 degrees is I know why that came about. There were a lot of failures on slopes before that came about. There was a lot. I mean, there still is a lot, but I think it's come down a bit. I think.
Mm.
But before the EMA introduced that rule, yeah, failures were common on hillsides. Someone wall falls down and it
Yeah.
kills someone, and it's
Yeah.
not very pretty stuff.
And the main issues for failure is people not managing water, would you say?
Water and just not knowing how to proceed with excavations and stuff. Like I mean, you see it all the time. You go into hillside developments and people who just don't know, they cut wild. Um, and depending on the material, you may be allowed to cut wild. Huh? I'm not saying no, but I'm saying that doesn't apply to every scenario, right? And then a lot of failures I've seen on sloped ground, particularly in south or central downwards, is people not knowing where to put their soakaways, their septic tanks. Those stuff leak all the time. And that's also part of the EIA as well. You have to say where those things go.
Mm-hmm.
And we can position that in a way where it doesn't affect your structure,
Mm.
right? Your foundations, your the long term. Because I mean, it is going to leak. I mean, that's what it's designed
Yeah,
to
that's
do,
what it
right?
does.
Yeah.
Yeah.
So it will. So we, in fact, a recent answer I've been on, um, that's in Saparia, I believe. Yeah, that was the cause of his landslip.
Right.
Uh, I mean, again, you can't blame people because they just don't know who to call, right?
Right.
Um, so you call, so for this one, the septic tank, Sukhoi, was in the middle of the retaining wall. And the retaining wall went to the septic tank. And yeah, I mean, it's unfortunate, but I mean, simple things like that could have been avoided
Yeah.
had you called. Yeah, even if thing is, I mean, these things become simple. Even if you pay to say you call a geotechnical engineer or even a civil engineer to take a look at it and say, well, does this plan make sense to you? And obviously, flags will raise, and you would say, no, you should put your septic tank here, or put your drainage on this side, or do this instead, you know? And then again, these are not major cost changes to your
Mm-hmm.
design. It's just a matter of shifting. You haven't built yet, it's just a matter of shifting it from X, Y.
Mm-hmm.
Yeah.
Yeah, it's I mean, I think it's difficult to demonstrate the value until it's too late.
Unfortunately, sometimes,
Unfortunately.
yes.
Yeah.
Yeah.
Great. Well, that's all my questions. Let's open it up to see if anybody has any additional questions for you. Thank you so much, Aaron. That was super informative. I'm
Yes.
happy. Well, I'm happy that we haven't had an event where liquefaction has occurred yet, because that's the big buzz thing now from like people sending videos of Indonesia on in WhatsApp groups. Have you seen that video?
Yeah, well, actually, it has a very, I mean, I don't want to interrupt the questions. I mean, you could just, because who would ask what they could ask, but one of my friends I studied with was from Indonesia in Imperial College.
Mhm.
And Indonesia is extremely seismically active, far more so than us. And they have on their coasts more like sandy material. Now, liquefaction primarily happens in free draining material. What does that mean, right?
Mhm.
Simple way to explain liquefaction. When you go on the beach and you tap the sand or you stomp on the sand, it gets like gel, right?
Yes.
That is liquefaction. Now, if you do that same thing, now let's say replace the sand with clay on a beach. If you do that, you could do that for years. Liquefaction will not happen because
Mhm.
the water can't permeate through that clay to liquefy that soil, right?
Mhm.
So Indonesia is prone to that because they are seismically active and they have the material that facilitates that phenomenon to occur.
Right. Right.
Yeah.
And that's pretty much like it's over.
Sorry?
That's pretty much it's over. You can't prevent that.
Yeah, I mean, there's a simple search on the internet will show you liquefaction occurring. It's terrible. I mean, New Zealand is one of those. Christchurch is one of
Mhm.
those areas. It's pretty bad. But again, it's not the end. I mean, we don't have to say our prayers.
Mhm.
Um, if you only have a thin layer of liquefaction, because that's something we also do, we assess it, let's say we do find an area in Trinidad that has this thin layer of sand that can liquefy, sand or silty sand, whatever it is. It may be liquefiable by only a couple inches, right? So then can you live with a couple inches? Possibly.
Yeah.
Maybe. So it doesn't always have to be that detrimental.
We have another question coming in here from Brent. Brent, you want to come off mute and ask us?
Sure.
Hey.
Good evening. Enjoying this thoroughly. Yeah, just a question here. I've always heard buildings south of Couva, I believe is a fault line that goes through Couva, that any building that is south of Couva needs piling. Is that a general rule, or is that just something that we non-geotechnical people I don't know.
Good question. Good question. I mean, I've heard that. I've heard that a lot. There's no easy way to answer that, because Trinidad's, just sorry to go back, but Trinidad's geology, geomorphology is so complex. Between meters, you can have completely different stratigraphy, right? So we have done projects south of Cuba on shallow foundations, as in no piling. I'm talking about 4-story, 5-story buildings south of Cuba on shallow foundations. So again, this is where geotechnical engineers come in. We can provide you a safe way to carry out those construction once we can carry out our investigations. So the answer is no. Just because you live south of Cuba does not mean you need piling. But I know people are concerned because of we do have the central range faults, but data has proven that it is not very seismically active, right? So there's no immediate threat from it as of now. I think there's a paper published right now on UDCOT's website, because remember, the Children's Hospital was built very, very close to that fault line. So there's a paper on the UDCOT website. You probably find it in the center on the
so that's another way a geotechnical engineer would save you as well, because then if you go with common knowledge, you'd put piles in, which will cost you more.
Of course, of course.
Nice. Any other questions? That was a good one, Brent.
Thank you very much. That was great. Actually, the Children's Hospital is always considered because of that. Or I could say perceived perception that anything south of Cuba. But
right.
I will definitely put a report. Read information.
Oh, brilliant.
All right, great. Thank you.
Yeah. Anybody else? Any other questions? You can still put them in the chat box. Any advice, any parting words you'd like to share?
Just one question. Sorry. All right. So, So my my training is getting into building information modeling. So these reports, because of BIM is more of a life cycle of a building or a space. These reports are done and forwarded in what form, like a PDF format, or just trying to see how these things could live for the life cycle of the project.
Okay, that's a good question, actually. It's a good question for me because I'm the younger generation of geotechnical engineers, and we're always looking for new ways to advance the field. As I said, make it more palatable with the other disciplines. Generally, the reports go in PDF formats. However, we also work on things where, like, you talk about BIM modeling, right? Yeah, we also do things like subsurface models, right? So that would go with the structural drawings. Yeah, so that's another aspect, another area of the field that now that we have technology to do it, LiDAR mapping, and then we have seismic surveys. geophysical surveys with boreholes, we can now map the subsurface a bit more accurately and put that into your structural model, your BIM, your overall model, and now decisions can be made in real time with everyone on board. It's a lovely tool, actually.
That sounding right up my alley. Because the thing about it is that, as I said, you just like you want to see decisions being made on the structure, architecture, or any discipline really. The geotechnical report information could inform so much more, down the road. So it needs to live somewhere that is accessible by everyone on the design team or the client side as well. So it's just trying to read information.
I guess it needs to be a part of the life cycle document.
Definitely.
All right, Aaron, we're coming up to our closed off time. So any closing words for the audience? Any pointers, anything to look out for? We'll definitely share your contacts with our mailing list to just in case anybody has any further questions they want to ask.
Yeah. Just to be mindful of where, my calls, is on my mind because my calls for the past few months have been primarily residential. Interestingly, is because of all these slips. And it's just my part, just be mindful. Just be mindful of where you build, how you build. Be mindful of where your neighbors develop. Sometimes you may not be the issue. Your neighbor may develop upstream of you or downstream of you. And you may think all is well and good. They put up a retaining wall. You don't question the integrity of that wall. And then a couple of years you find out, well, time to move, right? So it's just to be mindful, be observant, try to do things the proper way. I know it's not always easy because of costs and all that good stuff, but yeah.
And would you say if you're planning to buy land on hillside, get advice from a geotechnical engineer before you purchase?
Of course, sometimes, as I said, just sometimes a simple site visit to work with you, the client, the architect, if they have one, and the engineer, and you discuss what is your plan, what do you want to do, how do you want to cut this thing, do you want to go 2 stories down, 2 stories up, what is your plans? And we can immediately give you preliminary advice and tell you how shall you proceed. And that simple visit, whether it be 800 to 1500, whatever the cost is of that visit, can save you millions or thousands in the end.
Yeah. All right. Thank you so much. And we'll talk soon. And for everybody who joined us, thank you very much. And hope to see you on the next one. Aaron?
Yes, thank you for having me.
Take it easy. Bye, everyone. Later.